All right, in this video I'm going to be working Algebra 2 Quiz 3.2, which is just more absolute value inequalities. So we're going to start off with these kind of four special cases, and we're going to give the values of x that make the inequality true. Okay, so less than 0, absolute value less than 0, that never happens. Absolute value is either 0 or positive, so this would be no solution. Okay, and then x minus 1 greater than 0, that sounds like always, but remember, absolute value could be 0 or positive. Okay, so we need to account for when it's 0, this inequality wouldn't be true, right? So if x minus 1 is 0, it's not true, otherwise it's going to be true. So x minus 1 is not 0, that's where x is not equal to positive 1. Okay. Less than or equal to 0, well, that's pretty much never, except for when that absolute value would equal 0. And we see that absolute value would equal 0 when x is equal to 1. So this is x equals 1 only. And then over here, 4x minus 1 is greater than or equal to 0. That's always all real numbers. Okay. Now we're going to find the values of m that satisfy that inequality, and we're going to give our answer in interval notation. Okay, well, if the absolute value of a number is less than or equal to 9, okay, then that number has to be between negative 9 and 9. So if we have the absolute value of m minus 4 is less than or equal to 9, then m minus 4 is going to need to be the thing that's between negative 9 and 9. Okay, and now I'm going to just solve this inequality by adding 4 to all three sides. And it said give my answer in interval notation, so I'll say negative 5 up to positive 13, including both endpoints, because it was less than or equal to. All right, number 6. Find the values of x to make this inequality true, and then we're going to give our answers a sketch on the number line. Okay, so I'm going to start by adding 2 to both sides. Negative 22 plus 2 more would be negative 20. And then I'm going to divide both sides by negative 4, which will, switch the direction of my inequality. And then, okay, now I've got it down to absolute value inequality number. I think about the number line. Where's the absolute value of a number greater than 5? Out here, where the number is bigger than 5 or where the number is more negative than negative 5. And then from there, I will say, all right, this thing right here, this inside of the absolute value, that's what needs to be bigger than 5 or more negative than negative 5. So x plus 1 is less than negative 5, or maybe x plus 1 is greater than positive 5. And then I'll subtract 1 from both sides of both inequalities. And then, okay, we want to answer a sketch on the number line. Okay. Less than negative 6 or greater than 4. Okay, there we have it. I'll write on the back side. Now we're going to find the values of y that make this inequality true. Right, the absolute value of 10 minus y is less than or equal to 2. Okay, we've got it all already down to absolute value inequality numbers. So the absolute value would be less than or equal to 2 between negative 2 and 2. Right, and then, well, then I'm going to say that 10 minus y, that's what needs to be between negative 2 and 2. So I'm going to start by maybe subtracting 10 from all three sides. Okay, yeah. Wait, I feel like I've done, yeah, wait, I need to subtract 10 from both sides. This felt wrong. It's going to be, and then I'm going to divide both sides by negative 1. I guess both sides of both inequalities. And then it's going to reverse my directions here. So I'll have 12 is greater than or equal to y, which is greater than or equal to 8, which, if we were going to write it as an interval, we'd need to say 8 to 12 that way. But if you're going to leave it as an inequality, at least in this class, that would probably be all right. And then number 8, find the values of t that make this inequality true. Right, well, we're going to subtract 3 from both sides. Absolute value of 5t plus 1 less than or equal to negative 2. Right, and wait a second, absolute value less than or equal to negative 2. Absolute value is never going to equal negative 2. It's never going to be less than negative 2. So I'm going to say this one has no solution. And now we've got f of x equals this. Find the values of x that make f of x greater than 0. And well, I've got a formula for f of x. And we'll just set that greater than 0. We'll just solve it like we've been doing this whole time. Okay, so 2x plus 5, absolute value is greater than 3. Okay, we've got it down. We're going to think about where is the absolute value of a number greater than 3. Okay, definitely out here. But also back here. Okay. So this 2x plus 5, it can be less than negative 3, or it can be greater than positive 3. Subtract 3. Subtract 5. Wait. I subtracted 5. Subtract 5. I might have said subtract 3. I didn't mean that. Okay, and then I'm going to divide by 2. Divide by 2. And now I've got myself, these are values of x. So I could throw a box around that. Or if I wanted to write this in interval notation, which I have not written one of these in interval notation yet, I would say negative infinity up to negative 4. Okay, not including negative 4 because it's a strict inequality. Or union, negative 1 to positive infinity, right? Because it's where x is greater than negative 1. Okay, that was Form A. Let's do Form B. All right, now we're going to start with these 4 special cases. Okay, absolute value is greater than 0. That's almost always, because our options for absolute value are 0 or positive. This is positive. Okay, so we just, if the absolute value was equal to 0, this inequality wouldn't be true. So I just need the absolute value of, or I need the thing on the inside of the absolute value. I need x minus 2 to be not 0. So that's just as long as x is not 2. Okay. Over here, greater than or equal to 0. Okay, those are our 2 options for absolute value. Okay, so this is always going to be true. This absolute value could come back equal to 0. It could come back positive. Okay, so this would be always true. You could say always. You could say all real numbers. Whatever you want. I feel like infinitely many solutions does not actually capture the totality of the solutions to this inequality, though. Because it could be, there's infinitely many solutions to all of these inequalities that have any solutions at all, except for this type right here. Okay, but maybe I'll talk about that more on number 5. Okay, so when negative absolute value doesn't come back negative, that one has no solution, or you could say never. And then less than or equal to 0, less than isn't going to happen, but equal to 0 could happen if we were taking the absolute value of 0, which would be where x minus 2 is equal to 0, and that would be x equaling 2. Okay. Now on this one, we're going to find the values of m that make the absolute value of m minus 9 greater than 4. Okay, it's already down to an absolute value inequality number, so we just got to think about where's the absolute value of a number greater than 4. The absolute value would equal 4 at 4 and negative 4. And if that number was greater than 4, its absolute value would be greater than 4. And if that number was more negative than negative 4, its absolute value would also be greater than 4. So I'm going to go over here and say m minus 9 is the thing that needs to be greater than 4 or less than negative 4. Okay. And then I'll subtract or add 9 to both sides of both inequalities. Put a little or in there, and it said give my answer in interval notation. So if m is less than 5, that's negative infinity up to positive 5. Okay, not including 5, so we're going to put a parenthesis there. Or is union 13 to infinity. Okay, and parentheses around the infinity because always, right? Infinity is not a real number. X can't equal that, or m can't equal that. Okay, but if you think about this is going to be an infinite number of solutions, right? There's already an infinite number of numbers between negative infinity and positive 5, and then there's even more over here. But it's not the case that all real numbers make this inequality true. So I feel like if you say infinitely many solutions on one like this, you're not entirely right. I mean, you're not wrong, but you haven't grasped the totality of the solution to the inequality. Okay, now here's another one. We're going to find the values of x for which this inequality is true. And we're going to give our answer as a sketch on the number line. So I'm going to subtract 12. And divide by negative 4. Okay, you want to divide both sides of an inequality by a negative number. It reverses the direction of the inequality. And so I say, all right, absolute value of x plus 1, that's less than or equal to 3. I think about where the absolute value of a number is less than or equal to 3. That would be between negative 3 and positive 3. All right, so this x plus 1, that's what needs to be between negative 3 and positive 3. I'm going to subtract 1 from all three sides. Okay, and I've got this written as an inequality, but they want it as a sketch on the number line. And there we go. Notice also that there's an infinite number of solutions to this inequality, right? It's everything in between here, but the real numbers are very dense, and you can find as many numbers as you like between negative 4 and 2 if you just look hard enough. All right, on to the back. All right, so this next one is already down to absolute value inequality numbers, so I'm just going to be thinking about where the absolute value of a number is less than 10. And that would be between negative 10 and positive 10, right in here. And so that's this 2 minus y between negative 10 and positive 10. And then I'm going to subtract 2 from both sides of both inequalities. And then I'm going to divide both sides by negative 1, which will reverse the directions of the inequalities. Okay. And then I will say, okay, if I, wait. Yeah, that's got to be negative 8. That didn't feel right. And so then if I wanted to write this as an interval, I'd say this is from negative 8 to 12, including neither of them, because those are strict inequalities. All right. There's 2 more. Finding the values of t that make the inequality true. We're going to start by subtracting 3. Okay, and the absolute value is greater than or equal to negative 2. That's always true because the absolute value is going to come back 0 or positive, so I'm going to say this is true for all real numbers. Okay, and then number 9, we're going to let f of x equal this absolute value function, and we're going to find the values where f of x is greater than or equal to 0. Okay, f of x greater than or equal to 0. Okay, so I got to do a little solving first. Get it down to absolute value inequality number. Then we can think about where the absolute value is bigger than or equal to 5. So there we are. We're over here. And back here. Okay, so the absolute value of a number is greater than or equal to 5. And I'm going to say, all right, this 3x plus 2 could be less than negative 5. Or 3x plus 2 could be greater than or equal to 5.
No one else dressed up.
Oh, right. And then I'm going to subtract 2 from both sides of both inequality. All right, so I'm subtracting 2, and I'm subtracting 2, dividing. And then I've got myself, solution. If I needed to write this as an interval, I guess there's 2 intervals. I'd say less than or equal to negative 7/3 is negative infinity up to negative 7/3, including 7/3 but not including infinity, or is union 1 to infinity, including 1 because it's greater than or equal to, not including infinity because you never include infinity. All right, that's all for this video. Hope it helps.